So welcome back and let's keep going. So we're still on exam 1 from 2014 fall semester and we're on question number 22. It says how many resonance hybrid structure can be drawn for the carbonate ion? What is the formal charge for the carbon atom in a molecule, whatever. So this is particular. Yeah, by the way, I switched to a new program so it should work better, hopefully, somehow, whatever. Anyway. And so this is a formal charge problem, and what we should start with a formal charge problem is to calculate out how many valence electrons do we have in the entire molecule. So carbon has 4, and oxygen for each have 6, and there's 3 oxygen in total. So this will give us 22, and plus there's a, so you can see there's a 2 negative, there's a 2 negative charge over here. So hold on a second. Let's keep going. So there will be 2 extra electrons over here, and that will result give us 24 electrons in total. And so if you remember the rule of drawing Lewis structures, we need to put like the most electropositive atom in the middle, and we use the electro like the atoms with a relative with relatively electronegative atoms just surround the more electropositive atom, and we just connect them with a single bond first in order to form a molecule. And there are 3 bonds over here, so we'll subtract 3 bonds times 2 electrons for each bond, so it's 24 minus 6, which still leaves us with 18 electrons. And we just try to give the electrons to the atoms surrounding the center atom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and with a negative 2 charge. So this looks quite reasonable at this moment, but actually it's we can still make a little bit adjustment in order to make this better. And because for the second step we need to look up the formal charge of each atom. And the way to look up formal charge is like the numbers of valence electrons in the beginning minus the electrons we have right now. And that will give us the formal charge. The formal charge is over here. And so oxygen used to have 6, and now it has 1, 2, 3, 4, 5, 6, 7. And each bound count as 1 electron, because that kind of makes sense for like when like bond is kind of the idea of 2 atoms sharing electron between each other. So like actually for each bond it's just like 1 electron has been owned in this particular situation. And so that will result a -1 for the particular uh, uh, oxygen atom, and there are 3 identical oxygen atoms in this molecule. And carbon has 4 electrons in the beginning, and now it has 3 bonds around it, so now it has a formal charge of +1, or positive. And there's definitely a way we can lower this by I'll just draw it over here. By moving one of the, like, we just move one of the pairs. Uh, we just move one of these pairs into here to make a double bond in order to lower the overall charge of this particular atom, for this particular molecule. So it could be like something like this. And this looks much better with this has a formal charge of 0, this has a formal charge of 0, and this too has a formal charge of -1. And the formal charge are exactly on the atoms with a higher electronegativity. Higher electronegativity. And please do pay attention that formal charge never appears on the on atoms with a lower, like positive formal charge always appears on atoms with a higher positivity, and negative formal charge always appears on atoms with a lower with a higher electronegativity. So uh, this particular form does make sense. And there's like if we move around, like if we just rethink, if we just re-go through this particular uh, uh, process, we can find like there's actually three three structure can be drawn with this idea. So this was 2 minus, 2 minus, and there's the third one like this. Okay, so like there's as we can all see, there's 1, 2, and 3 hybridization. So we can eliminate answer. I should get a red pen sometimes. So just pretty color over here. We can eliminate this. We can eliminate this. We can eliminate this. And as we can see in the beginning, the formal charge, is always 0 on the carbon cation, on the on the carbon atom. So the correct answer is D. And we'll end here. How they're supposed to end it.